Hey everybody, welcome back. It's time to talk about balancing equations. We have been working on counting atoms for quite a few days now, but now it's time to put all of that knowledge of counting atoms to work to balance some equations. So on the back of those counting atoms notes, we're going to go to our balancing equations information. Remember the other day when I introduced you to pentane and we saw some of it burn in that chemistry lab? Yeah, I'll show you that video again in just a minute. But when pentane combines with oxygen, it burns. Burning is one of many different types of chemical reactions. In a type of chemical reaction, a new substance is made. So the atoms of pentane are still there. They've just been rearranged to make something new. Let's see that video again. I'll show you what I mean.
Here's pentane on the countertop of the Woo! Well, there's not a lot of smoke. It's pure alkane, so we're good. Cool.
Alright, so in that video clip, we saw the pentane, which was liquid, clear, looks like water, dumped on the table and then lit on fire. When the pentane was lit on fire, the chemical reaction caused the bonds to break between the different atoms in the molecules. It looks like the atoms vanished, but they did not vanish. That pentane that we saw changed into carbon dioxide gas and water vapor molecules. So all of those atoms are still there. They've just been rearranged to make something a little bit different. The name of this is called the law of conservation of matter. New substance, but same amount of atoms. The law of conservation of matter states that matter cannot be created nor destroyed, but can change forms. That means all the atoms that went into a reaction also must come out of a reaction. It may not be the same substance, but the substances are going to be made with the same atoms as before. Let's look a little bit more deeply at that pentane reaction. The substances that go in and get changed are called the reactants. So over here on the left-hand side of any equation are our reactants. C5H12 is pentane, 1 molecule of pentane, plus 8 molecules of oxygen. If you mix these two things together, there is a chemical reaction. All of the bonds break apart and the atoms rearrange themselves to make products. The products are found on the right-hand side of the equation. In this case, the products are 5 molecules of carbon dioxide and 6 molecules of water. Things that go in are reactants. The things that come out are products. If we were to count up all of the individual atoms, we would notice that all the atoms, the number of atoms on each side of the equation are the same. The amount of atoms on the reactants and the amount of atoms in the products are the same amount. For example, pentane is H12. On the other side, we still have 12 atoms of hydrogen, but they make up water instead. Okay, here's a closer look at that chemical reaction in the equation we were just talking about, the reaction between pentane and oxygen. As you can see, for every single element, the same amount of atoms that went in that are in the reactants, the same amount of atoms are in the products. They're just rearranged to make something new. You still have 5 atoms of carbon on one side as you do on the other. C5 during pentane, then they're chemically rearranged to make 5 molecules of carbon dioxide. Both sides still have 5 carbon atoms. As mentioned before, each side still has 12 hydrogen atoms. 12 over here, 6 times 2 makes 12 over here. And even oxygen, 8 times 2 is 16. On the other side, 5 times 2 is 10, plus 6 more makes 16. Let's look at one of pentane's family members. This is methane. Methane is CH4. It also reacts with oxygen and burns to make carbon dioxide and water. The equation written below is not balanced, but we need to figure out how to balance it. We already know that CH4 is 1 atom of carbon and 4 atoms of hydrogen. CH4 and oxygen react to make carbon dioxide and water. It's our job to figure out how much. So we know that it takes 1 molecule of CH4, but how much oxygen does it take? And then how much water comes out on the other side? We can figure this out by balancing the equation. So far I've filled out what we already know. We already know we have 1 atom of carbon on each side of this equation. Let's figure out how many atoms of the other substances need to be on each side to be in balance. Let's start with what we know. Let's start with hydrogens. We know we have 4 atoms of hydrogen on the left-hand side of the equation in the reactants. What do we need to do on the right-hand side to get 4 hydrogen molecules, or hydrogen atoms? We already have 2 hydrogen atoms with H2. What times 2 is going to equal 4? How are we going to get 4 on both sides? I think by adding another hydrogen atom, 2 hydrogen atoms, by adding another water molecule, we are now going to get 4 hydrogens on this side. We have 4 hydrogens in the products, we have 4 hydrogens in the reactants, so now we have 4 hydrogens on each side. Now let's look at our oxygens. Now on the right-hand side we have 4 oxygens, 1, 2 in carbon dioxide, and we have 1, 2 in our 2 molecules of H2O. How are we going to balance this equation to make sure we get 4 oxygens on the other side? What times 2 equals 4? Aha! 2 molecules of oxygen. That's what's going to give us what we need to be in balance. So now we have CH4 plus 2 O2s is going to give us the same amount of atoms as carbon dioxide and 2 molecules of water. Everything is in balance. Look at the pictures. When in doubt, draw it out. Draw those pictures in order to see actually how many atoms are on each side of the equation. This is called balancing an equation, and we're going to get lots of practice with this in class. All right, we're going to start getting to work. Thanks for listening and have a great day.